The topic is the sampling distribution for proportions p-hats. So let's do this example. A candy company claims that its jelly bean mix contains 15% blue jelly beans. So we know that P is equal 0.15. So this is like the population proportion. Suppose the candies are packaged at random in small bags containing about 200 jelly beans. So we know N is equal to 100. What is the probability? Let me write it here. What's the probability that a bag will contain more than 11%? So a bag contain 11% means P hat is equal 11%, right? To 0.11. So P of P hats, we want this to be bigger than 0.11. So this is the question, right? So assume that the condition for the sampling distribution for sample proportions of sample with size n equal 200 are met. But let's assume even if it was not met, we could check it easy. Can we check the simple random sample? Yes, I mean this is the definition. I'm looking here. The definition says you need to check all these four. So SRS is easy to check. Why? Because let me read this. Suppose the candies are packaged at random in small bags. So S simple random sample is checked. We need to check that NP is bigger or equal than 10. What is NP? NP is equal, N is 200 right there. P is 0.15. If we multiply them together, you will get 30, which is bigger or equal than 10. Again, what is N times 1 minus P is equal, N is 200 times 1 minus 0.15. If you use a calculator, you're going to get 170, bigger or equal than 10. What about the last one? So we check this, What about number 4? N is equal what? In our case, is 200. Is this less or equal than 10% of the population size? Meaning, is this less or equal than 10% of all jelly beans? Of course, of all jelly beans. So checking the conditions is not as hard. Now we know we have the sample distribution. Not only that, by definition we know its formula, the formula for standard deviation of p hat, and the formula of standard deviation of the mean of p hat. So we know the mean of p hat is just going to be a BP, which is 0.15. I got it from here. And then we know that standard deviation will be equal, P is 0.15 times 1 minus 0.15 is 0.85, divided by N is 200, and then take the square root of all that. So if you use your calculator, you're supposed to get 0.0252. 0.0252. Alright, so how do we calculate? Now let's go back to the problem. We need the probability of p hat being bigger than 0.11. So where's 0.11? It's right here. 0.11. So we need to find this area. So how do we find this area? We go from 0.11 to a huge number. Let's call this 1,000, for example. So that would be what? Using the calculator would be normal CDF of what? We're going from 0.11 to a huge number bigger than 4 standard deviation. In our case, 1,000 will work. So 0.11 to 1,000. And then standard, then the mean is right here, 0.15. And the standard deviation right there is 0.0252. And use your calculator, supposed to get 0.9437, which is 94.37%. And that's it for this example.